With number 23, they just want to test your wording. Okay, so they want you to know, or they give you this graph, and it says at which positions will a crest and a trough overlap. So you should know if it's a crest and a trough that move in the same direction, or towards each other rather, that we will have a deconstructive interference. Because remember, if we have two crests or two troughs that collide, if we can say that, or overlap, we will have constructive interference. So here we have an intensity curve. So you should know that at the tops, we have here position 1, 2, and 3, and there's position 4 and 5. The tops of the intensity curves is where we have constructive interference. Okay? So we will have two troughs or two crests that overlap. But here at the bottom positions where 4 and 5 is, we will have our deconstructive interference, and that is when we look at the intensity curves where we will form dark bands. Okay? So at position 4 and 5 we have our deconstructive, meaning a crest and a trough that overlap. Okay? So your correct option here will be B at position 4 and position 5, where we have our deconstructive interference. Cool. Here with number 24, we have the diffraction pattern of blue light. Okay, and they want to know to increase the diffraction. Okay, so we want to have more diffraction. Which one of option 1, 2, 3, and 4 will be our correct changes that we need to make when we want to increase our diffraction? Okay, so remember diffraction. Okay, they said blue light, and I drew this before I read it. So blue light travels, okay, and then it hits a gap or a slit. All right, and then we will get our diffraction pattern that we see there. Okay, so the first thing that you need to know is you need to know your 7 colors. Okay, and you should know that from red light to violet over here, we have long wavelengths, and it's decreasing to shorter wavelengths. Okay, we also have low frequency as well as energy, where we have high frequency and high energy on the right hand side of our visible light spectrum. Okay, so there's not a legit definition or a legit formula that we can use, but you should know that with diffraction, I'm going to write it as diff, with diffraction, as your slit increases, okay, you'll see that this diffraction pattern will decrease. Okay, so the width of the slit, W, the width, has to do with something. Okay, so if we need to check a proportionality, you'll see that the diffraction will increase the closer the slit's width will be. So that is W. So that's an inverse proportionality. Okay, but if we decrease the wavelength, we will also see the same thing. So how will we increase diffraction? By increasing our wavelength. So from blue light all the way to a longer wavelength red light, we will get more diffraction. Okay, so we can see that diffraction is directly proportional to the wavelength. So if we increase diffraction, we're increasing our wavelength, and if we're decreasing our width of this slit over here, we will increase diffraction as well. So the only option will be the number 2, that says we will have an increase in our wavelength, and number 1 that says a decrease in our diffraction, the width. So the correct option will be D, that states exactly that, what we just said.